We're going to skip section 6.5 and 6.6. We'll come back to those in a bit, but we're going to now talk about electrolysis a little bit more. So electrolysis, which is officially 16.7 in our textbook, electrolysis means you have to add voltage to a reaction to make something possible. And this is how they make aluminum metal. They also can make silver metal and stuff. It's not too hard of a thing to figure out how much you need. So these electrolysis problems are kind of interesting. They usually involve amounts going to time elapsed, or it's time elapsed going to amounts. And I'll talk about that here in a little bit. You'll see some things about current, which usually gets the symbol I, and current usually has the symbol amp. All right, a unit of amp is a coulomb per second. So every time you see an amp, I just want you to think coulombs per second. And if you happen to see the symbol I, just realize that's amps, that means coulombs per second. We'll also need the Faraday constant, 96,485 coulombs per mole of electrons, to make this happen. So with both coulombs per second and coulombs per mole of electrons in the Faraday, you can go from the time to the amount, or you can go from amount to time. And let's talk about that. This is the kind of question you might see. You've got a current of 1.50 amps. And again, remember the amp just means coulomb per second. And honestly, I would just cross out amps and put in coulombs per second. So we have a current of 1.50 coulombs per second. It's flowing through a silver plus solution for 15 minutes. And the question is, how much mass of silver metal is deposited? Okay, so notice in this question, we're starting with a time, and we want an amount, a mass, or moles, or something like that. And it's not too hard to figure out. What we're going to do in this problem is we're going to turn minutes into seconds, 60 seconds per minute. Then we can use the current, which is units of time on the bottom and coulombs on the top. We'll use the time elapsed and the coulombs per second to find how many coulombs charge has been passed. We can use the Faraday to convert coulombs into moles of electrons. And notice we have silver plus going to silver, and it's going to take 1 mole of electrons to turn 1 mole of silver plus into silver. So it's a 1 mole of electron per mole of silver ratio, and that'll be important to us. So the first thing like I would do, every time you see amp, just think coulombs per second. And that's helpful because in a 60 seconds per minute, you can kick out the seconds. And remembering we're doing this for 15 minutes, so the minutes cancel, the seconds cancel, we're left with coulombs. 1,350 coulombs have been transferred in that 15 minutes. Now, from the coulombs, you can use the Faraday constant, 96,485 coulombs per mole of electrons, to figure out how many moles of electrons that means. So 1,350 divided by the Faraday, 0.0140 moles of electrons have been transferred in that 15 minutes. And then because we want mass, grams, of silver metal, well, it's 1 mole of silver is made for every mole of electrons transferred. So the moles of electrons equal moles of silver, and you can take the moles of silver and multiply by the molar mass of silver, which is about 107.8 grams per mole. That comes out to be 1.51 grams of silver. So if you want to make silver metal from a silver plus solution, and you apply 1.50 amps of current for 15 minutes, you should create 1.51 grams of silver. So in this problem, we have a battery. It's lead going to lead 2 plus. 2 electrons are created per lead. And we want the battery to deliver 1.50 amps, 1.50 coulombs per second. And if the battery has a pound, which is 454 grams, how long will the battery last? So you don't want your battery to die on you in the middle of the wilderness. You want to know how long the battery is going to be good for, and you can absolutely do that. We're going to use the fact that there are 2 moles of electrons for every 1 mole of lead, and we have 454 grams of lead. So grams of lead to moles, a mole of lead is 2 electrons. There's Faraday constant, coulombs per mole of electrons, and finally coulombs per second will allow us to go to time. So let's see how all this works out. Start with the grams, turn them into moles. We'll take the 454 grams of lead, divide it by the molar mass of lead, which is roughly 207 grams per mole. That'll give us the moles of lead that are present, 2.19 moles. Every mole of lead creates 2 moles of electrons. That's what the balanced reaction there is saying. 1 mole of lead creates 2 moles of electrons. So every mole of lead will create 2 moles of electrons. That's 4.38 moles of electrons being created. The Faraday constant allows you to go from moles of electrons to coulombs of charge. Coulombs are a way to measure the charge. So when you multiply the moles of electrons by the Faraday, you get 423,000 coulombs of charge being transferred. And we have here in this case an amp of 1.50. That means 1.50 coulombs per second. So hopefully you see where we're going with this. We have 423,000 coulombs and 1.50 coulombs per second. So when you figure out how this works, remember amp is like a coulomb per second, the time elapsed 282,000 seconds. And if you take that number, divide by 60 to get minutes, divide by another 60 to get hours, 60 minutes per hour, 78.3 hours is how long your battery should last. So hopefully that will be enough to keep you from getting stranded in the desert or whatever you need to do. This is how you go from amount in grams to time elapsed. It's basically the opposite of the process we saw in the earlier example. In this question, we're converting gold 3+ into gold metal. And the question is, how long, time, will it take to electrolyze, i.e. turn gold 3+ into gold? We want to know how long it's going to take to do this for 0.0100 moles of gold 3+. And we're using 2 amps, 2.00. That means 2.00 coulombs are being transferred per second. And we have all those different times down there. All right, no problem. So we have a total of 0.010 moles of gold 3+. It's going to take 3 moles of electrons to turn the gold 3+ into gold. So multiply the moles by 3 in order to find moles of electrons. We'll then multiply by Faraday, which is coulombs per mole of electrons, to find out how many coulombs that represents. And finally, we'll divide by the amps because that's coulombs per second, and we'll end up with a number of seconds. So if you do all of that, and here's the math involved, it comes down to 1,450 seconds. So again, here's the moles of gold. 3 moles of electrons are needed to turn that 3+ into gold. Gives you moles of electrons. We'll then multiply by the Faraday constant. Your moles of electrons will cancel, and you've got coulombs. And again, if you have amps, think coulombs per second. So 2.00 amps means 2.00 coulombs per second. The coulombs cancel. You've got just seconds. 1,450 seconds are needed.